Hey guys, Lauren here. So today we're going to be covering the basics of matrix algebra. So this basically includes things like matrix addition, scalar multiplication, matrix multiplication, and the transpose. So matrix algebra is a rectangular array of numbers. So this just means that the numbers are written in any kind of shape, but that could be like a rectangle, a square, all of the above. So as you'll see, that's going to be written next. There's different ways to call parts of an array. So what goes across the top horizontally is a row. What goes across vertically is a column, and all of the little numbers in each array is called an element or an entry. So each array has a certain number of columns, a certain number of rows, and a certain number of elements or entries. If a matrix has m rows and n columns, it is size m by n, which can also be written as m times n. So in the first example, A would be 4 rows times 3 columns. So it is size 4 times 3. And B is 2 by 2. That's also known as a square matrix. To distinguish between each element or entry, you call the rows I and the columns J. So for A11 would be the first row and the first column, and in this case, that's number 1. If you do A12, which is the first row and the second column, that would be number 2. And if you did A23, you would go over to the second row and over to the third column, and then in this case, that's 0. If a matrix has a single row or a single column, it's called a row vector or a column vector. This is because there is only one single row or one single column. And here I'm just writing about the specific entries in each matrix. So, as an example for a row vector, it would just be in a straight horizontal line, and say it had 3 entries, it could be 1, 2, 3. Or a column vector would be just up and down, so vertically, like 4, 5, 6. I'm just going to let the writing catch up, and then I'll explain the next point. So next we're going to cover matrix addition. This is pretty simple, simpler than a lot of the other stuff that we're going to cover, like matrix multiplication. Say we have 2 different matrices, A and B. Both are going to be 3 by 2 matrices. That's wrong. Sorry. Both are going to be 2 by 3 matrices, which means that they have 2 rows and 3 columns. So A has 1, 2, 3, 4, 5, 6, and B has 1, 0, 5, 2, 3, 7. We're going to call C the addition between A and B. So any entry in C, say Cij, is equal to Aij plus Bij. So C11 is equal to A11 plus B11. As you can see in the example, C11 is equal to A11 plus B11, so that's 1 plus 1. C22 is is equal to A22 plus B22, so 5 plus 3. And then you're going to add up each of those additions, and that'll be your C matrix. So 2, 2, 8, 6, 8, 13. The next thing we're going to cover is scalar multiplication. If a matrix, let's call it A, and there's a scalar k, which is just a number, then Ka is obtained by multiplying all entries by k. So this would mean that you take a matrix A and multiply each and every value in A by the value k. So say k would be 2 or 3 or any number. The same would be for this one, so C is equal to Ka, or Cij is equal to K times Aij. So say you have C11, that would be equal to the value of A11 multiplied by K. The next thing we're going to cover is matrix multiplication. An important point about matrix multiplication is that it is not entry by entry product. So this means that it's different than scalar multiplication, where each entry was multiplied by the scalar. In order to do this, we need to remind ourselves what the dot product is. This should have been something that you would have covered in either high school or in a basic math course before you took linear algebra. What's important about the dot product is that it's not just multiplying each vector by each other. You're multiplying the first entry, so A11 times B11, adding it to A12 times B12, and A13 times B13. The dot product is very useful for a lot of different courses, such as physics or all kinds of math courses as well. So in our example, we have A is a column vector. A is a row vector and B is a row vector. And so A dot B would be 1 times 0 plus 2 times 1 plus 3 times 2. This is equal to 0 plus 2 plus 6, and in total the dot product is 8. So if A is a m by n matrix and B is an n by p matrix, then AB is a matrix composed of dot products of the rows of A and the columns of B. So I'm just going to draw a little diagram explaining what this means. But basically, you're going to take the row of I and multiply it by the column J of B, and you're going to get a matrix of size Ij. So what's important is that the column size of A is equal to the row size of B. So if you have m by n and n times p, the two n's are equal. This would mean that you're going to get an answer of size m by p. So you're going to get the row I of A, the column J of B, and this is going to equal Cij where Cij is the dot product of row I of A and column J of B. This is kind of confusing, but it'll make more sense once we see an example. Matrix multiplications can be used in all kinds of different word problems that you'll see in linear algebra to help you solve for anything, especially if you're doing things like elimination. You'll have your matrix A multiplied, say, by an X matrix, and then which is equal to an answer, and then you'll have to eliminate some of the values to solve for what the X values would be. So in our example, we're going to have A, which is a 2 by 2 matrix, also known as a square matrix. This is 1, 2, minus 1, 1. And we're going to have B, a 2 by 3 matrix, which is 1, 2, 3, 1, minus 1, 2. And so what that would mean is, since the column part of A and the row part of B are equal, we're going to be left with a matrix of size 2 by 3. So we're going to take these two matrices and multiply them together. So this is where the dot product part will come in. We're going to take the first row of A and multiply by the first column of B, but we're not just multiplying it, we're going to take the dot product of the two. And then for the next one, we're going to take the first row of A, multiply it by the second column of B, and the first row of A times the third column of B. And then for the bottom row, we'll do the same steps, except for we're going to use the second row of A, multiply it by the first column of B, and then so on. And then we're going to break it down into the dot product. So for the dot product, what we'll do is we'll take the first entry as an example. It'll be 1 by 1 plus 2 by 1. So you're taking the first number in the first row of A, multiplying by the first number in the first column of B, adding that to the second number in the row of A and the second number of the column of B. And we'll do that for each entry. It's a little tedious writing each step out, but as you get more comfortable and you have more practice doing all of these steps, it'll become easier and you won't have to do and write out each individual step. You can just do the dot product in your head once you get a little bit more practice. So now we're going to add each value together. So for the first entry of this new matrix C, we'll get 1 times 1 plus 2 times 1, which is 3. And then we'll keep doing that, so that'll be 3, 0, 7, 0 minus 3 minus 1. And now the final topic that we're going to cover today is the transpose. This has a bunch of different uses that you'll see throughout your linear algebra course. This just has different types of properties and different uses in matrix algebra. So if A is an m times n matrix, the transpose of A, denoted A superscript T, is obtained by writing rows of A as columns of AT. So this means that, say we have an example A, which is a 3 by 2 matrix, the A transpose will become a 2 by 3 matrix. So you're basically switching the orientation of the matrix, as you can see in the example that will be written. So A has 3 rows and 2 columns, whereas A transpose has 2 rows, and 3 columns. The transpose also has a couple different properties that are important for linear algebra. As you'll see written, the transpose of A transpose just brings you back to your original matrix A. A plus B to A plus B in brackets transpose is equal to A transpose plus B transpose. And then A times B transpose is equal to B transpose plus times A transpose. Thank you guys for watching. I hope you guys learned a lot.